Hi, and welcome back to Algebra 1. Our goal for today is to continue working with our process of factoring polynomial expressions, and more specifically, factoring polynomial expressions that have degrees of 2, which are quadratics, and higher, which require both looking for what's called the greatest common factor to factor out, plus going a little bit further to what's called the chart method to factor completely. So at this point, I should understand that factoring is the breaking up of an expression back into things or individual terms that can be multiplied back together to get the original expression. So in this case, once we're done, we should be able to go back and do multiplication and see if we match the original problem. If we multiply out our factors we get in the end using FOIL method or distribute method, whatever we need to do to get to the final multiplied version, and it doesn't match the original problem, we know that we factored it incorrectly. Right? We're just rewriting an equivalent math problem, an equal math problem to what was originally there, but in its individual what are called factors. If you have a linear polynomial, please remember a linear polynomial just means your highest degree on a variable is a 1. In that case, the only thing you could do in the process of what's called factoring is pull out the greatest common factor. Right? That would get you to your factored completely version. If your degree on your polynomial is a 2, meaning it's a quadratic polynomial, then or higher, then you should be checking for both the greatest common factor, right, pulling that out front always first, and then trying to go further if possible using what's called the chart method. So our goal for today is continue working with, what if I'm presented with a trinomial, something that has 3 terms, right? We should be at the point where we understand if we have 4 terms, like this problem here, what's called a quadrinomial, a polynomial with 4 terms. We look for our GCF first. If this leading coefficient is negative, please remember a negative has to get pulled out in front as the GCF, even if that means all we pull out is a negative or a -1. So don't forget, it's a special rule you have to remember. Then once you have your GCF factored out, you take your 4 terms to your chart and you go row by row and column by column to do the remaining portion of your factoring. We should be at the point where we are able to do those problems perfectly well at this point. So our goal for today is to continue looking at what if we only have 3 terms called a trinomial to start. All right, we should be good with these top 2. I can do GCF for linear. I can do chart and GCF when I have 4 terms, and then we're going to continue working here where we have 3 terms, and we have to take this middle term and break it up in a special way so that we're prepared to go to our chart method. So again for today, just like last week's last video, or our previous video, I should say, we are going to just do the beginning part of this process of taking it from a trinomial to its equivalent quadrinomial that's going to help us do the factoring process. And then starting tomorrow, we'll actually do the entire process of GCF factor, going from a trinomial to a quadrinomial, going from that quadrinomial to our chart, doing our row by row, column by column, and finishing the entire factoring process. So again for today, can we just get set up so that we could do the factoring process? So we're back in our notebook where we left off in our last lesson, how we write trinomials as their equivalent quadrinomials. Please remember we had a hot dog bun fold in the middle of our notebook paper, and we were working one side for our steps and one side for that scratch work that helps us find that magic combination of how to break down that middle term into its 2 equivalent terms. So we're picking up from there. In our last lesson, we did the first, I believe, 4 together. So we're going to pick up from there. So number 1, we said, here's your reminders. You take your leading coefficient and your constant term. You multiply those 2 things. That gives you the number you're looking for over here. You need things that when you multiply, you get that number. And when you add them up, it has to give you that middle term. Now, keep in mind, this expression here would have to be in simplified standard form before you do that part of the process. So if I gave you the problem, for example, if I gave you -2r plus r squared minus 3, something like that, you would have to rearrange it to its simplified standard form of r squared minus 2r minus 3 before you go leading coefficient times constant term. So just be careful. Once you find the magic combination that works, you're taking that middle term and breaking it apart in that special way. So picking up from our examples last lesson, number 5. All right, 6q to the second plus 7q minus 5 is our original quadratic polynomial expression. Since our degree is a 2 or higher, we need to look for both greatest common factor and chart method. To be able to go to our chart method, we need 4 terms called a quadrinomial. So that's our goal for today. How do I get this 3 terms to an equivalent version that has 4 terms so I can do the factoring process? All right, 6q squared, 7q, and negative 5 do not have a common factor. All right, so there's no GCF for this one, so we can go straight to our guess and check our scratch work. All right, we take our leading this is in standard form, so we take our leading coefficient of 6 and our constant term of negative 5. When we multiply those, we end up with negative 30. So we need factors of negative 30 that when we combine them or add them up, we get that middle number of 7. Now remember, when your factor number over here is a negative, so I have 1 times 30, right? That would give me 30. But I need the result to be a negative. So one of these numbers, either the 1 or the 30, would have to be a negative. Be careful with your signs. All right, that means 1 times negative 30 is also an option. 2 and 15 is a combination that gives us 30. So negative 2 and 15, or 2 and negative 15 is an option. 3 goes into 30, so 3 times 10 would be a combination. So one being negative 3 and 10, the other one being 3 and negative 10. The next number that goes in is 5 with 6. And that's actually all of our combinations here that would give us negative 30. So we're looking for the one that when we add up the digits, we end up with a positive 7. All right, this would give us a 29. This would give us a negative 29. This would give us a 13. This would give us a negative 13. All right, negative 3 and 7, or 10, excuse me, gives me a positive 7. That's our good one. Not this 3 and negative 10, because that will give us a negative 7. All right, so here's our magic combination that works for this particular problem. So we're taking this 7q, and we're going to say instead of 7q, we're going to write it as negative 3, still with a q, and 10, still with a q. And that's how we get to 4 terms. We're taking 1 term and breaking it up into 2 pieces. We still have this 6q squared, and we still have this minus 5. And now we would be ready to go to our chart. Box 1, box 2, box 3, box 4 for our chart method to help us do our factoring. All right, number 6. I want to prepare to factor by getting this trinomial to its equivalent quadrinomial. So 6x squared minus 30x plus 36. I always have to look to see if there's a GCF factor first, even when using the chart method. It's my first step of factoring, no matter what type of polynomial we have. So 6x squared, negative 30x, and 36 all have a common factor of 6. I have to factor that out first before I go to my guess and check chart to see how to take the trinomial to a quadrinomial. All right, left over would be x squared. Right, negative 30 divided by 6 would give us minus 5x, and 36 divided by 6 would give us a 6. All right, this 6 is a factor, and it's done. So now we're just working with that quadratic polynomial of x squared minus 5x plus 6. All right, our leading coefficient here is a 1. So 1 times 6, we need factors of 6 that add up to negative 5. All right, we have 1 times 6. Or negative 1 times negative 6, right? Those would both give us a positive 6. We have a 2 times 3 or a negative 2 times negative 3. Right? Those are our combinations that when we multiply, we end up with a positive 6. All right, this one here would give us 7. This would give us negative 7. This would give us a 5. And then here's our magic combination. Negative 2 plus negative 3 would end up giving us a negative 5. So that's how we want to break apart this negative 5x. Instead of writing it as negative 5x, we're going to write it as negative 2x and negative 3. So we have a 6 out front. That's done. In here, we still have an x squared term. We're just breaking up this middle term into 2 pieces of negative 2 still with an x and negative 3 still with an x. And then we have that back term of plus 6. And now we would be ready to do the factoring process. box 1, box 2, box 3, box 4 when we go to our chart. All right, one more together. We have an x to the third plus a 7x squared minus 18x. We want to factor by GCF and chart method ultimately. And the way to do that is to pull out our GCF if there is one, and then take our trinomial, make it an equivalent quadrinomial. So in this case, every term has a common factor. They all have at least one x, so that's our GCF. We need to pull it out front. And what would be left, or we could say it's 1x, right? That would be the other way to write it. 1x came out, so there's still 2 here. One of these x's came out, so there's still 1 here. And then this 1x came out, so all that's left now inside here would be the negative 18. All right, this x is done, right? It's a factor, and we have to keep going with the quadratic trinomial x squared plus 7x minus 18. All right, we need leading coefficient here, 1, and that constant term of negative 18. So 1 times negative 18, we need factors, or numbers that multiply together that give us negative 18. And when we take those digits and we add them up, we get a sum of that middle x to the first term coefficient of 7. All right, we need a negative here. So 1 and 18 would be a combo. One of them has to be negative. So these are my two options with 1 and 18. All right, 2 goes into 18, 2 and 9. So negative 2 and 9, or 2 and negative 9. 3 goes into our 18, which is 3 and 6. 1 has to be negative. All right, those are our combinations. Again, if you already know the combination, you don't have to list them all out, right? This is your scratch paper work. Just make sure you do your guess and check until you end up with the magic combination that does work. All right, negative 1 and 18 would give us a 17. All right, that's a fail. This would be a negative 17. We're looking for positive 7. Negative 2 and 9, that would give us a positive 7. So as soon as I got to this one, right, wherever I got to that one in my guess and check would be my stopping spot. I found my good one. So instead of positive 7x, we're going to write it as negative 2 with an x and 9 with an x. Everything else is still there. We still have this x out front. We still have this x squared. We're taking 7x. We're calling it negative 2x and 9x. I could put the plus 9x here and the minus 2x here. The order doesn't matter, but it has to be those two terms. And then subtract 18. And then we would be ready for our chart method. Box 1, box 2, box 3, box 4 would get us to being able to factor the rest of the way. All right, I hope that helps you for today. I will see you guys later.